So now you hopefully have a good understanding about how to use normal distribution to approximate distribution of proportion of your sample. So we can talk about the other way around. So if you know proportion of your sample, how to make an inference about proportion of your population, for example, how to find confidence interval for proportion of population, or how to make a test. We will still use the normal approximation. Remember that it has its limitations. It doesn't work well, actually, if your proportion is too small or too large, meaning close to 0 or close to 1. But otherwise, if this rule is met, if this requirement is met, then you can simply replace proportion of your population to proportion of your sample when you compute a variance and standard error, so this one, of the interval. Okay, so strictly speaking, we still assume that proportion of our sample is normally distributed around proportion of our population, and then we compute variance based, the standard error based on the proportion of the sample. So let me show you a couple of examples again. Let's formulate a problem. Let's say we tested a new medicine and we tested it on 500 patients. And then we found out that 98 out of these 500, they developed a side effect, which is migraine. It's a terrible headache if you don't know. So our goal is to answer two questions. First of all, so in this case, you can see that 98 out of 500, it's almost 20%, right? So how big this proportion is if we talk about the whole population. And also, let's imagine that we have a certain requirements that we can release this medicine if the proportion of migraines is below 25%. For the population. So we need to test if this proportion is indeed below the 0.25. Let me answer both questions using the normal distribution approximation of the population distribution, and then we will compare the answers using a more sophisticated and more reliable method. Okay. So let's start with first one. What proportion of migraines we can expect from the population? So in this case, apparently we need to compute confidence interval for the proportion of population. So this is the proportion. So it's a little bit below 20%. This is the sample size. And then we need to compute the variance, right? So we compute variance similarly to what we have done before, but now we use proportion of the sample instead of proportion of the population. So this is the proportion of the sample. This is p hat, right? And this is 1 minus p hat. And then you have a sample size here. Okay. So that gives us approximately 0.0003, and then we take a square root of this of the variance, and that gives us a standard error for the proportion. And then you can see the standard error is approximately 1.8%. Now we can compute confidence interval, and first of all, we need to define what confidence level we use. Again, we need to define confidence level. We need to agree on confidence level before you actually start doing anything. Imagine that we decided to use 99%, so in this case the z-score will be 2.58, plus minus 2.58, minus for the left boundary, plus for the right boundary. So we can compute error margin by taking z-score times the standard error of proportion, so that's my error margin, and then you can compute confidence interval by taking this plus minus error margin to the proportion of your sample, and that gives you the proportion of the population. And here I made a mistake because this should be pi, of course, because it's a proportion of population we compute the confidence interval to, right? Confidence interval for. So you can see that this is the confidence interval for the population proportion. So if we talk about population with 99% confidence, we can expect that the number of migraines will be between 15 and 24.2% with 99% confidence. Okay. Now we can do the same calculations in R. You can see that I use a function that is called prop test. It can both compute confidence intervals and make tests. So this is the number of observations I have for a particular category, the one that I use the calculate proportion for. This is a total number of observations. So in this case, 98 is how many migraines I observed in my test, and then 500 is a total number of patients. And then I also provide a confidence level. And then you can see pretty long outcome. We need, in this case, only 99% confidence interval. This is what is it. And then you can see that it's between 0.153 and 0.246. So you can see it's kind of shifted a little bit towards the middle, right? And that's exactly what I said, that the smaller proportion is, the closer it's to 0, the less reliable the calculation using normal distribution. But nevertheless, you can see that the values are pretty close. So we have only difference in the third decimal in this case, in this particular case. It's pretty accurate estimation. Okay. So this is it. And now in the next small video, you will watch how to calculate confidence interval based on your sample proportion. Again, play with this, try different sample size, try different proportions and so on and so forth. And then come back to discuss how to solve the second part of the problem.